Hey everyone, and welcome back to The Explainer. Today, we are tracking a genuinely fascinating, kind of hidden mechanic of our modern future. We're calling it the journey of the Joule. We're going to follow the overarching story of our hardworking electric vehicle batteries, from the literally massive scale of their creation to keeping them running smoothly on the road, all the way to their surprisingly complex afterlife. Let's get right into it.
So, we're currently building millions of electric vehicles every single year, right? It's a completely monumental shift in how humanity moves. But this rapid transition presents us with two very distinct, very urgent challenges. First, what happens when these vehicles run out of charge on the road? And second, and honestly equally important, what happens when those batteries completely run out of life and are headed for a landfill? How we actually answer these two questions is going to define the true sustainability of this whole EV revolution.
All right, let's kick things off with part one, the global battery boom. To really wrap our heads around the scale of these challenges, we have to start at the source. According to data analyzed by the United Nations Development Program, by the year 2030, global demand for lithium-ion batteries is projected to hit an absolutely astounding 4,700 gigawatt-hours. To put that into perspective, that is a more than six-fold increase from just 2022. And over 80% of this demand is driven directly by the mobility sector. Our electric cars, trucks, and commercial vehicles. When you break down that explosive growth, it's wild to see how visually striking it is. Two regions really stand out. China and Europe are driving the absolute lion's share of this demand. And within those regions, the mobility sector just completely dwarfs consumer electronics or stationary storage. We are quite literally paving the world with lithium-ion cells.
And naturally, with that kind of global demand comes some staggering economic scale. This transition creates a super exciting $300 billion revenue opportunity across the entire battery value chain by 2030. We're talking about everything from mining and refining to cell manufacturing and eventually reuse and recycling.
Moving right along, let's jump into part two, keeping EVs on the move.
Before we even worry about a battery dying permanently, we got to look at the micro level, the individual driver's daily experience. If you've ever driven an EV or even thought about buying one, you definitely know the fear of range anxiety. It's that awful dread of a dead battery with no charging station in sight. So, how do we conquer this before it leaves us completely stranded?
Well, there's this company called Be Charged EV, and they are totally flipping the traditional charging model on its head. Instead of you driving to a static station, their predictive smart charging AI proactively monitors your car's battery in real time. It actually sends a personalized alert when you're running low, and with one single tap on your phone, it dispatches a mobile charging unit right to wherever you are. It's basically magic.
These mobile units are essentially busy little bees delivering 65 to 70 kilowatts on site, giving you a full charge in just 20 to 30 minutes. And what's really cool is their Apex 300 program, which specifically targets charging deserts, communities that have been largely ignored by public infrastructure. They're rolling out units to service fleets in all 50 U.S. states, and they're aggressively expanding into Mexico City to support rideshare and Uber drivers. By bringing the power directly to the drivers, they completely bypass the 18 to 24 months it usually takes just to get utility grid approvals to pour concrete.
Which brings us to the next stage in part three, the coming battery tsunami.
Because eventually, no matter how many times you conveniently recharge it, an EV battery degrades. The UN Development Program highlights a seriously looming ecological wave. Contrast that massive growth stat we talked about earlier with this. By 2040, we are expecting an unfathomable 20,500 kilotons of global lithium-ion battery waste. It's really hard to understate the sheer scale of this. We are looking at a compounding 25% annual increase in end-of-life batteries year over year. And get this, 94% of that waste is coming directly from post-usage EVs. This is a literal tsunami of heavy metals and chemicals, guys. If we aren't prepared for it, our green transition could so easily become an ecological nightmare.
But don't panic just yet. Let's look at part four, the battery afterlife pathways.
Here is where the story actually gets really inspiring. We absolutely need to bust a major myth here. A dead EV battery isn't really dead at all. When it degrades past the point of being useful for the high-performance demands of accelerating a 2-ton car, it typically still has 70 to 80% of its original capacity left. It still holds incredible potential. It's honestly just ready for a new job. The UNDP report outlines this beautiful, continuous loop we can build.
It charts the journey from raw material production, right through the active life of the battery, and ultimately into the critical paths of reuse and recycling. Instead of just dumping them in a landfill, batteries enter a system of evaluation where they get sorted into one of 3 R's.
So, the first R is refurbish. Sometimes the battery cells themselves are perfectly fine, but maybe a wire is frayed, or the battery management system, which is basically the digital brain of the battery, has failed. Refurbishing simply involves healing these damaged parts so the pack can happily return to its original vehicle, easily extending its life on the road for years.
Now, the second R is repurpose. If the modules aren't really fit for a fast-moving car anymore, they're given a second life in lower-demand jobs. A prime example from the report is utilizing them for stationary energy storage systems, or ESS. Imagine taking old EV batteries and beautifully connecting them together to store excess power from solar panels or wind turbines, and then feeding it back into the grid when the sun goes down. It's brilliant. In fact, Nissan, BMW, and Toyota are all running pilot projects doing exactly this right now. And the final R is recycle. For batteries that are truly at the absolute end of their chemical life, we completely disassemble them down to the cell level. Through advanced processes like pyrometallurgy, which uses extreme heat, or hydrometallurgy, which uses liquid chemicals, we extract what's called the black mass. These precious gems, things like lithium, cobalt, and nickel, are recovered and fed right back into the very beginning of the loop to make brand new batteries.
All right, let's bring it all together in Part 5, Building a Sustainable Loop.
So the big question is, how do we actually turn this ideal flowchart into a reality on a global scale? Well, the UNDP's analysis of the developing market in Thailand really highlights our hurdles here. Right now, end-of-life management is pretty messy and fragmented. There are no specific laws dedicated to battery management, which leads to risky disposal. Even worse, repurposed batteries are often taxed like brand new ones. That completely destroys the financial incentive to recycle. To fix this, we urgently need structured producer responsibility, rigorous national tracking systems, and specific tax incentives to make the afterlife pathways economically viable.
As the UNDP report states so perfectly, there is an urgent need for a consistent framework for end-of-life battery management and the development of a recycling industry. This framework is absolutely crucial. Without it, the economics of recycling just fail. With it, we ensure safety, we dramatically enhance environmental protection, and we support the sustainable growth of the entire EV sector. And that really brings us to the core of our explainer today. The electric vehicle revolution is fundamentally meant to be green. But we really have to stop and ask ourselves, is it truly sustainable if we don't plan for the end of the road? Whether it's an AI-dispatched mobile charger keeping you moving today, or a cutting-edge hydrometallurgy plant recovering your battery's lithium tomorrow, the technology exists. Now, it's just up to us to build the system. Think about the devices powering your life right now. What is their afterlife going to be? Thank you so much for joining me on this journey today. Keep learning, stay curious, and I'll see you on the next explainer.